Kubernetes, design patterns and extensions. Kubernetes has become the de facto standard for orchestrating containers. As the world of software development is embracing microservices, solutions like Docker have become more and more popular. Running thousands of Docker containers is no easy task though, and that's where Kubernetes comes in to fill the void. Designed by Google, this prominent open source container orchestration system makes managing complex setups not only possible, but even easy. With Kubernetes, you can run distributed clusters to provide reliable and scalable applications running in isolated containers. This means that Kubernetes is typically installed on multiple redundant nodes, and if one of these is taken offline or fails, Kubernetes makes sure that the containers or replicas that were on the failed host are created elsewhere. In a connected world where you have customers around the globe, it is important that you can scale your application to ever-changing needs. Kubernetes lets you easily add or remove nodes to your cluster and thus dynamically change how many requests can be managed by your application. There are many players in the container orchestration market, and some of them have been in the public domain much longer than Kubernetes. Docker Swarm, for example, has been around for longer than Kubernetes and has even been officially integrated into the standard Docker tooling. Though both of these open source orchestration platforms provide much of the same functionalities, Kubernetes offers the larger feature set. Take auto-scaling your application based on CPU utilization. This is something you do with Kubernetes. However, Docker Swarm doesn't support this feature. You would have to monitor your cluster via some other solution and then manually scale your application. Not only does Kubernetes offer more features and can handle more nodes and containers, it also has support of the community behind it. If you compare the number of news articles about Kubernetes, the number of Google web searches, the number of GitHub stars, contributors and commits with Docker Swarm, Kubernetes has over 80% of the market share. Kubernetes is also more popular with developers because many continuous integration solutions offer great support for Kubernetes. GitLab CI, GitLab's continuous integration tool, can create a brand new test environment in Kubernetes to run automated tests in whenever developers push code to their GitLab server. Another huge advantage of Kubernetes is that it overcomes the limitations of the Docker API. Docker Swarm is integrated with the Docker tooling, so if you're planning to do something that isn't possible with Docker or Docker Compose, Docker Swarm won't let you do it either. Let's say you want to take a node out of your cluster for patching and you want to drain all the containers that are running on it onto other nodes first. The Docker API won't let you do that. However, Kubernetes supports a drain command to do exactly that. This is just one of the many examples where Docker and Docker Swarm API fall short and no proper tooling exists in Docker Swarm, but it does in Kubernetes. For developing on Kubernetes or running it in production, you should follow best practices. Some of them are having only one process per container. Although it's technically possible to have 20 processes in one container, how would Kubernetes know whether the container is healthy or not? Log everything to standard out and standard error. By default, Kubernetes listens to these pipes and sends the output to your logging service. On Google Cloud, for example, they go to Stackdriver logging automatically. Don't rely on the latest or no tag at all. If you don't add a tag to your container, Docker will always try to pull latest from the repository, and that may or may not contain the changes that you think it contains. Use readiness and liveness probes. Probes can be used so that Kubernetes knows if nodes are healthy and if it should send traffic to them or not. By default, Kubernetes checks if a process is running or not, but by using probes, you can leverage this default behavior and add more advanced logic to it. A common misconception about Kubernetes is that it's complex and overwhelming. The platform itself, though, is elegantly designed with only the necessary building blocks. The reason Kubernetes is considered so complex is that, unlike the platform itself, the necessary tasks needed to build a Kubernetes cluster are overwhelming. Developers often lack the exposure to system administration tasks like securing communication via SSL certificates or configuring proxies and load balancers. It's the complexity of these initial tasks and the troubleshooting steps involved in getting the cluster just right that lead to the misconception that Kubernetes is hard to use. So, whether you're a developer working with containers and have no prior Kubernetes experience at all, or you're a Kubernetes administrator and want to get more out of your cluster, this course is for you.